Now let's move to our next topic, which is composition of function. Now, what do we mean by composition of function? Suppose we have got three non-empty sets, set A, B, and C. And suppose there are two functions f and g, where function f is from set A to set B, and function g is from set B to C. Now, function f is defined as to every element x in set A, there exists a corresponding unique element f of x in set B, and the function g is defined as to every element f of x in set B, there is a corresponding unique element g of x in set C, or we can say to every element x in set A is associated to a unique element f of x in set B, and every element f of x in set B is associated to a unique element g of x in set C. So this also means that for every element x in set A, there also exists a unique element g of x in set C, which gives rise to a new function f from set A to set C. And this is called as composition of function f and g. And this composition of function f and g is denoted by GOF. Now let's try to understand the concept of composition of function with the help of an example. Remember, in your class 10 board examination, each student is assigned a unique roll number, and after the exam is over, the students hand over the answer sheets to the board officials. And now, so as to make this process confidential, the exam officials overwrite each roll number with another coded value. That means every roll number has got a new coded number associated with the roll number. So that means if set A consists of the students of class 10, then corresponding to each student, there exists a roll number in set B, which is generated by the function f, and corresponding to each roll number in set B, the function g of x generates a coded number in the set C. Now, this also means that each student has also got a unique coded value. So, this gives rise to another function which is from A to C and which is denoted by GOF. And this function GOF is called as composition of function f and function g. So that means if we have got a function f from set A to set B and another function g from set B to set C, and now suppose we have got any element x which belong to set A, then there always exists an element f of x which belong to set B, and corresponding to this value f of x, there also exists an element g of f of x in the set C, and this function g of f of x is called as composition of functions f and g. Now I will discuss the preconditions for existence of composition of function. Now suppose if f and g are two functions, then g of f exists if range of f is a subset of domain of G, and function f of G exists if range of G is a subset of domain of f. Now, I will explain the composition of function with the help of an illustration. Now, you can see in the picture there are two machines, f of x and g of x. The machine f of x receives the input x, and after processing this value x with the help of function f of x, it generates an output f of x. And now this output f of x becomes input for another machine g of x. And again, g of x will process this input value and generate another value g of f of x. And this value g of f of x is called as composition of function f and function g. That means to every input x, there is a corresponding unique value g of f of x, and which is denoted by g o f. Or that means to every input x, there is a corresponding unique value g of f of x, and which is denoted by g o f and is called as composition of function f and function g.